So the last video for lesson 15 is going to be talking about transformations. So recall our assumptions of multiple linear regression is that our variance is normally distributed, our residuals are normally distributed, our residuals are centered around our mean, our residuals are independent, and our residuals have constant variance. And so sometimes our residuals don't have constant variance. And when we check this through looking at the predicted versus residual plots, we notice that this assumption does not hold. Some of the remedies that we can look at is looking at a weighted least squares approach, which what this does is it's just going to weight the data a little bit differently. To help adjust for that. We won't talk about this in our class, but if you're interested in this type of idea, you can look at weighted ordinary least squares or just weighted least squares. What we're going to be focusing on is transforming our response or our yi. And the example we're going to use here is this energy example where we have a yi, which is going to represent the peak demand, and xi, which is going to represent the monthly energy usage. And the whole idea is that this energy company wants to examine the relationship between these two. And we have 51 customers. So if we were to just look at the data untransformed for the energy use, we would have on our left hand plot is the usage or our X, and our demand, which is our Y on the Y axis. And if we're looking at this, we can kind of slightly hopefully notice, it's a little bit hard, there's this kind of variance trend, and we have a very fan-like pattern. And when we plot our predicted versus studentized residuals, we get to notice that fan even more. So for lower values of our, we notice that we have a smaller variance compared to larger values of our predicted, where we have a larger variance. Okay, so that's what I mean by here, tighter dispersion for the smaller values. One common transformation for the data is a log transformation. And in this case, and in this class, when I say log, I mean natural log. I'm not thinking any crazy bases, I'm thinking natural log. Just as a preface, or just as a note, I know some fields don't have that, but our log is the natural log. So when we do that, and again, when we are doing this transformation, you pretty much are just taking the log of your response, and then that's what we plot. So we have our x's here for usage, and then we're just plotting the log of our y response, and we get this trend here. I can't notice too much from this specific plot, but if we move over to our studentized residuals versus predictor, you'll notice that there is a little bit tighter, kind of something roughly, but there's a tighter dispersion for our larger values, and then for our smaller values, we actually have a larger kind of variability. So it's almost the opposite of our untransformed data. So this is going to violate, again, our assumption of constant variance. And another common transformation is to do the square root transformation. And in this case, after we take the square root of our transformation, we plot our predicted versus residuals, we start to notice a fairly evenly dispersion of our residuals. Okay, now, so far, I only really talked about two transformations, the natural log and the square root. There are more other common transformations here. which are used. But there is also a more formal test called the Cox Transformations, which you're gonna look at if you're interested in finding a power transformation. In this class, we won't go into detail for this Cox transformation, but I'm telling you about it, just so you're aware of that's an option. Okay. Typically, what we do as researchers is we try several different transformations and choose the one that is the most stable. When you're using transformations, use one that is easier to interpret. You may also need to adjust some of your predictors. Predictors after looking at those partial regression plots that we talked about in the last video. And a key point that you also should remember is to untransform your predicted responses when you're interpreting your confidence intervals and prediction intervals. Okay, now I'm going to jump over to jump quickly just to demonstrate how you would input the transformations into your data as an example. So I just want to be completely transparent about this. When you transform your response, all we're going to do is we're going to go to in jump or in R, new column. We're just going to do the square root of demand. Column properties, formulas. There's a lot of different ways you can do this. We're going to edit the formula. And we're just going to take the square root, put 2 up there. Number is demand. Okay. Okay. Now we're going to go to analyze, fit model, square root of our demand, usage, and we're going to run. And what we get is this plot right here, which we saw in our notes. For our notes, I used R, because why not? But here in jump, you get the same thing, and we're looking at our residuals versus predicted. And that's it.